The fascinating world of LIDAR technology. Applications in electric vehicles and beyond. LIDAR, an acronym for Light Detection and Ranging, is a revolutionary technology that has transformed industries ranging from autonomous driving to environmental monitoring. By emitting laser pulses and measuring the time it takes for them to return after reflecting off objects, LIDAR creates precise, three-dimensional maps of the environment. This technology, once confined to niche scientific applications, is now a cornerstone of innovation in the tech world, particularly in the realm of electric vehicles, EVs. In this video, we'll dive deep into how LIDAR works, its various applications, and why it's becoming indispensable in the EV industry. How LIDAR works. The basics. At its core, LIDAR operates on a simple principle. It uses light to measure distance. A LIDAR system consists of a laser emitter, a scanner, and a highly sensitive detector. The laser emits rapid pulses of light, sometimes millions per second, which travel outward, bounce off objects like buildings, trees, or cars, and return to the sensor. By calculating the time it takes for each pulse to return, known as time of flight, and factoring in the speed of light, LIDAR determines the exact distance to those objects. What makes LIDAR truly powerful is its ability to generate a point cloud, a dense collection of data points that form a 3D representation of the surroundings. Modern LIDAR systems can achieve centimeter-level accuracy, even at long ranges, making them far superior to traditional radar in terms of precision. Unlike radar, which uses radio waves, or cameras, which rely on visible light, LIDAR's use of lasers allows it to function effectively in diverse lighting conditions, including complete darkness. LIDAR's evolution in the tech world. LIDAR's roots trace back to the 1960s when it was first used for mapping terrain from aircraft. However, its high cost and bulky size limited its widespread adoption. Fast forward to the 21st century, and advancements in miniaturization, laser technology, and computing power have made LIDAR more accessible. Today, it's a critical tool across industries like archaeology, think uncovering hidden Mayan ruins, forestry, measuring tree canopy density, and even gaming, creating hyper-realistic virtual worlds. But perhaps the most exciting application of LIDAR lies in the automotive sector, specifically, in the rise of electric vehicles and autonomous driving. As EVs become the future of transportation, LIDAR is playing a starring role in making them smarter, safer, and more efficient. LIDAR in electric vehicles, the autonomous driving revolution. Electric vehicles are already transforming the way we think about transportation, with companies like Tesla, Rivian, and Lucid leading the charge. But the integration of LIDAR into EVs takes this innovation to the next level by enabling fully autonomous driving. Here's how LIDAR is shaping the EV landscape. Enhanced perception for self-driving cars. Autonomous EVs rely on a suite of sensors, cameras, radar, and ultrasonic systems to see the world around them. LIDAR complements these by providing unparalleled depth perception and accuracy. For example, while cameras struggle in low-light conditions and radar lacks fine detail, LIDAR can detect a pedestrian crossing the street or a cyclist in the bike lane with pinpoint precision, even at night or in fog. Companies like Waymo and Cruise, which are developing autonomous EV fleets, heavily rely on LIDAR to navigate complex urban environments. Mapping and localization. LIDAR doesn't just detect obstacles, it helps EVs understand where they are in the world. By comparing real-time point clouds with pre-existing high-definition maps, LIDAR enables precise localization. This is crucial for Level 4 and Level 5 autonomy, where the vehicle must operate without human intervention. Imagine an EV taxi picking you up in a crowded city. It uses LIDAR to know exactly which lane it's in and how to merge into traffic seamlessly. Safety and redundancy. Safety is paramount in autonomous driving, and LIDAR acts as a failsafe. If a camera misidentifies an object due to glare or a radar signal gets distorted, LIDAR provides a reliable backup. This redundancy is why many experts argue that LIDAR is essential for achieving true autonomy in EVs, despite Tesla's camera-only approach sparking debate in the industry. Efficiency in EV design. LIDAR's compact, solid-state versions are now being integrated into EV designs without compromising aerodynamics or aesthetics. For instance, Lucid Motors has partnered with LIDAR manufacturers to embed sensors into its sleek Air sedan, ensuring both performance and range, key priorities for EV buyers. Beyond EVs, LIDAR's broader tech applications. While EVs are a headline act, LIDAR's versatility extends far beyond the road. Here are some other groundbreaking applications. Urban planning and smart cities. LIDAR-equipped drones map cities in 3D, helping planners optimize traffic flow, design sustainable infrastructure, and even simulate flood risks. In smart cities, LIDAR sensors on streetlights could monitor pedestrian movement, enhancing safety and energy efficiency. But agriculture. Farmers use LIDAR to monitor crop health, measure soil elevation, and optimize irrigation. Drones with LIDAR can scan vast fields in minutes, providing data that boosts yields and reduces environmental impact. Archaeology and conservation. LIDAR has uncovered lost civilizations by penetrating dense jungle canopies, revealing structures invisible to the naked eye. It's also used to track deforestation and wildlife habitats, aiding conservation efforts. Robotics and delivery. From warehouse robots to last-mile delivery drones, LIDAR enables machines to navigate cluttered environments with ease. Amazon, for instance, uses LIDAR in its fulfillment centers to streamline operations. Challenges and the future of LIDAR. Despite its promise, LIDAR faces hurdles. Cost remains a significant barrier. High-end systems can cost tens of thousands of dollars, though prices are dropping as solid-state LIDAR, without moving parts, gains traction. Size is another challenge. While units are shrinking, integrating them into sleek EV designs requires ingenuity. Finally, there's the ongoing debate about whether LIDAR is truly necessary for autonomy, with Tesla's Elon Musk famously dismissing it as a crutch. Looking ahead, the future of LIDAR is bright. Analysts predict the global LIDAR market will exceed $10 billion by 2030, driven by EV adoption and smart infrastructure. Innovations like frequency-modulated continuous wave, FMCW, LIDAR, which offers greater range and velocity detection, are pushing the boundaries further. As EVs evolve into mobile computers, LIDAR will likely become as standard as electric motors themselves. In conclusion, LIDAR technology is more than just a tool. It's a game-changer reshaping how we interact with the world. In electric vehicles, it's paving the way for a future where cars drive themselves, reducing accidents and emissions. Beyond EVs, its applications touch nearly every corner of modern life, from uncovering ancient history to building smarter cities. As we stand on the cusp of this technological revolution, one thing is clear: LIDAR isn't just illuminating the road ahead, it's lighting up the possibilities of tomorrow. Units are shrinking, integrating them into sleek EV designs requires ingenuity. Finally, there's the ongoing debate about whether LIDAR is truly necessary for autonomy, with Tesla's Elon Musk famously dismissing it as a crutch. Looking ahead, the future of LIDAR is bright. Analysts predict the global LIDAR market will exceed $10 billion by 2030, driven by EV adoption and smart infrastructure. Innovations like frequency-modulated continuous wave, FMCW, LIDAR, which offers greater range and velocity detection, are pushing the boundaries further. As EVs evolve into mobile computers, LIDAR will likely become as standard as electric motors themselves. In conclusion, LIDAR technology is more than just a tool. It's a game-changer reshaping how we interact with the world. In electric vehicles, it's paving the way for a future where cars drive themselves, reducing accidents and emissions. Beyond EVs, its applications touch nearly every corner of modern life, from uncovering ancient history to building smarter cities. As we stand on the cusp of this technological revolution, one thing is clear: LIDAR isn't just illuminating the road ahead, it's lighting up the possibilities of tomorrow.